Alright, so for part A, I have the inclined segment right here. I have the block. And here I have the normal force. Here I have F of G. Here I have the force of F. And here I have F of K. Okay, now for B, I'm doing the contact force between the block and the inclined segment. So I'm going to use the net force. The net force is equal to mass times acceleration. But the acceleration of y, and the acceleration of y is 0. Because if it was anything other than 0, then the block would like start floating. So since the acceleration of the vertical direction is 0, I'm going to make a statement that the net force is equal to 0. And for the net force, we have 3 forces that are vertical. So we have F of n, and then we have F of g cosine theta, and then we have F of sine theta right here too. Equals to 0. Now I want to isolate for F of n, so I'm going to move all of this to the other side. And then F of g cosine theta can be expanded into mg cosine theta. Okay, now for part C, I'm going to use the same equation of the net force is equal to ma, but I'm going to use the net force of the inclined segment, so I'm going to write net force of f of x is equal to ma, and the net force would be f of cosine of theta, because this is the parallel, and then minus f of g sine theta, because this is the parallel structure right here, and then minus your friction, which is mu k fn, or mu fn, and we already found fn right here, so I can just plug this in. Like that. And then fg could also be written as mg. So with these two statements together, I can write the equation of f of cosine theta minus g sine theta minus mu mg cosine theta plus f sine theta equals to ma. And then I want to find the acceleration, so I'm just divide everything by m. Everything by m. Okay, now for part D, I'm going to do the net force on the inclined segment again. So I'm going to write the net force of x is equal to mass times acceleration. But this says that it's traveling at a constant velocity. So that means that the acceleration must be 0. So I can make a statement that the net force of x is equal to 0. Now we already know what the net force of x is right here, because we already found it. So I'm going to just write it again. F cosine theta minus mg sine theta minus mu mg cosine theta plus f sine theta. And then I can set these two together. Now, this equation is asking for the force of F, so we have to isolate for F. But first, I'm going to distribute the mu to the equation. So I have F cosine theta minus mg sine theta minus mu mg cosine theta plus mu sine theta equals 0. So I can rewrite this statement here to isolate for f because I have 2 matching f's and I have 2 matching mg's. So I can do f of cosine theta plus mu f sine theta minus mg sine theta minus mu mg cosine theta. Now this has matching f's and this has matching mg, so I can pull that out. Oh, sorry. Equals 0. Now, since it's moving at a constant velocity, that means that f has to be positive in order for the box to be moving up. So we can make a statement that f is greater than 0, and then f is equal to this whole equation right here. So we can say mg sine theta plus mu cosine theta over cosine theta plus mu sine theta is equal or greater than 0. Now this incline is from 0 to 90 degree, because if it was greater than 90 degree, then it would be over here. So this is from, so theta is from 0 to 90 degree. And from 0 to 90 degree, sine and cosine theta are always positive. So this top does not matter. What really matters is the okay, I kind of messed up, but the denominator should have a negative. I distributed it wrong, or I had the wrong signs. So what really matters is the denominator, because the denominator has a negative on the bottom. So what we're going to do is we're going to disregard the numerator, and we're going to set the denominator to this equation right here. Now I'm going to move the mu sine over here. And then I'm going to isolate for mu. So I'm going to divide. Whoa. I'm going to divide the sine over. So I have cosine theta over sine theta is greater than mu. And then cosine over sine is equivalent to cotangent theta over mu. And this is the relationship. This means that the cotangent must be greater than mu in order for the box to keep moving up. Yeah, I messed up around right here. This is supposed to be a negative, not a positive. Okay, now for part E, I'm going to write the equation that net force is equal to mass times acceleration. And I'm going to plug in the mass and the acceleration, which is 2 and 0.5. So net force is equal to 1. And then I already found the net force previously, which is F cosine minus mu sine theta minus mg sine theta plus mu cosine theta. And then I set that. So this is the net force as well. And then now that I have these two statements, I can set them equal to each other. So I have F equals 1. Now I can move this term over here. So I have F and then divide this. So I have F by itself. Cosine theta plus 1 over cosine theta minus mu sine theta. Now with this equation, I'm able to plug it into my calculator. So I have 19.6 because 2 times 9.8 is 19.6. And sine 20 plus 0.33 cosine 20. Yep, plus 1. Cosine 20 minus 0.33 sine 20. Yep, that'll give me around 16.67. So F is around 16.67 newtons. Positive 16.67 newtons. Now for F, I'm going to do the net force is equal to mass times acceleration. But here it says the system is motionless, so the A would be 0. So then the net force would just be 0. And then again, we already found the net force of F, which is F cosine. Yep, and then, but here it says that now as a block of 4m is now additionally placed. So we have m and 4m together. So then we have 5mg. And then we'll just set that equal to 0 because we can make an equation. And then we're just gonna move this to the other side and then divide by this. So we have 5mg sine theta plus mu cosine theta all over cosine theta minus mu sine theta. That is our equation. Okay, now with this equation, we're able to do part G. So then we have the net force is equal to MA. Net force is equal to 2, 0.5. So the net force is equal to 1. And we already found the net force previously, like this. So I can just write it again. So I have the net force is equal to F cosine theta minus mu sine theta minus 5mg sine theta plus mu cosine theta. So I can make a statement and set that equal to 1. And then you move this to the other side. One plus 5mg sine theta plus mu cosine theta. And then you can divide this part. So you have 1 plus 5mg sine theta plus mu cosine theta all over cosine theta minus mu sine theta. Now with this equation, I can plug into my calculator. So I'm just gonna put this part first, and then I'll add the plus 1 later. So I have 19.6 and sine 20 plus 0.33 cosine 20 plus 1 over cosine 20 minus 0.33 sine 20. And that will give us 83.33. So F is equal to 83.33 newtons positive. Okay, now for part H, unlike part B, this is the contact force between the two blocks of M and 4M. So I'm gonna do the net force in the horizontal plane, which is MA. But I'm gonna use the block of 4M. So I'm gonna do net force of X equals 4 ma. And then the net force for here would be F of m4m minus 4mg sine, which is the parallel from this part, and then minus the friction, which is mu 4mg cosine theta. And then I'm gonna set these two equal to each other. So I have F m4m minus 4mg sine theta minus mu 4mg cosine theta equals 4ma. And then we're finding the f of m4m. So I'm just gonna move everything. Oh my gosh, it is so blurry. I'm gonna move everything across this side, across the right to the right side. And then, okay, now with this equation, I can take out the 4m from all these terms. So I'm just gonna sub it out. So now I have g sine theta plus mu g cosine theta plus a. And then from the previous equation of g, I have all these terms already. So 4 times 2, and then 9.8. And then sine of 20 plus 0.33, 9.8 cosine 20, and then plus 0.5 for the acceleration. Now I'm going to plug this into my calculator. So I have 4, 2, sine, oh, sorry, 9.8 sine 20 plus 0.33 times 9.8 cosine 20 plus 0.5. That will give me 55.12. Okay, now for part I, now that these two blocks have been swapped around, I can make a statement that f of 4m, which is this block right here, is equal to 1/4 of f of m 4m, because this is 4 times more of the weight. So if I already have this weight right here, I'm going to divide by 4 and see what the contact force of this block is. So I have the previous saved equation answer right here. I'm going to divide it by 4. And that gives me roughly 13.7. So F of 4mm is equal to 13.7. You'll see that the force of Fm4m, which is the contact force of this block originally up here, is significantly greater than F of 4mm, which is the block of just 1mm. So I can make a statement that F of M4m is greater than F of 4mm, which by this statement means that the kid is wrong, because if the blocks were swapped around, then the contact force would not remain the same. So I disagree with the kid.